Okay. Yes, my name is Dr. Raja Latif. I am from Prince Mohammad bin Fahd University. Uh, that was fortunate for me that I studied this subject of topology by Dr. A.V. Ranjasky Valdemar from Russia for 3 years. And then I studied by Rainier Vogt in Germany for 2 years. And then I did my PhD from University of Alberta, Canada with Dr. Stephen Willard, who has written a book, still it is famous one. So therefore I work in this field of topology. Now this field has been extended a lot during the last several years. For example, fuzzy topology, soft topology, nano topology, micro topology, rough topology, and many others related fields, this one. And it has a lot of applications in other fields also. But anyway, in this research, I have taken up, I have written paper in soft topology and neutosophic topology and others ones. You may find it on the internet. But in this presentation, I'm going to take the nano-topological spaces. Here, Lalis Thiwagar introduced the notion of nanotopology by using theory approximations and boundary region of a subset of a universe in terms of an equivalence relation on it, and also defined nano-closed sets, nano-interior and nano-enclosure in a nanotopological spaces. In 2015, Rajendran, Ahmed, and Babu Sharmila introduced and studied a new class of generalization of closed sets, which are called Nano Generalized star semi-closed sets. And Nano Generalized star semi-open sets in nanotopological spaces. Analyze their just basic properties. The class of sets, namely Nano G star S open sets and Nano G star closed sets, are playing more important role in topological spaces because of their applications in various fields of mathematics and other fields of engineering and other science disciplines. This paper is devoted to the introduction of nano G star S separation axioms. Namely, the separation axioms involved are nano G star ST0 space, nano G star ST1 space, nano G star ST2 space, nano G star S regular space, nano G star normal space, almost nano G star normal space, mildly nano G star normal space, nano G star compact space, nano G star connected space, nano G star S closed graph, and strongly nano G star closed graph in nanotopological spaces. We have investigated the fundamental properties and characterizations of these spaces in nanotopological spaces. So here are some basic definitions and preliminaries of these, and the topics which I have covered it, I just named it here, and we have given basic definitions from this. These are so needed topology background for this for understanding. I don't want to go by letter of this here, right? Here is the definition that UTR of X be a nanotopological space. A subset is called a nano generalized star semi-closed set if nano semi-closure of A is contained in G whenever A is in G and G is a nano G open in U. This is the extension of the set theoretic topology. We are using the concepts of those. And this has more applications in general topological spaces nowadays. And then these are just basic definitions, and we have seen that this is a topology on topological space, and we have given some basic properties of these nano G star as closed sets and nano G star as open sets here, and then we have given some definitions of nano G stars continuous function, nano G star as irresolute functions, and nano G star open functions, nano G star as closed functions. And because we are going to use these functions in our results. So the first one we are going to take nano G star semi-separation axioms. In this one, we have given the introduction and the definitions of nano G star S T0 space, nano G star T1 space, nano G star S T2 space, via using the nano G star S open sets in nano topological spaces. So we are well aware of this, that about the definitions of T0, T1, and T2. This is just the extension we have used instead of ordinary open sets in topological spaces. We have used nano G star as open sets, and we have given their definitions. These all definitions are the same. And then we have studied some properties equivalent to those. These are some proofs of this. For example, a nano G star as nano topological space is nano G star as T1 space if and only if singleton is nano G star as closed in nano topological space. And we have given some more by using the definition of continuity here. This is a continuous function. This is and once this is T0 space, then this the domain space is also nano G star as T space. And then we have given the definition of T1 equivalent to this, and then we have given definition of T1 space as nano G star. We are talking here about nano G star T1 space. So that is the result which I just said about this one. It's the proof of this one. And then here is about the nano G star as irresolute functions. We have given the result of this. If f is a nano G star as irresolute function. Nano G star irresolute function means that the inverse image of each nano G star open set is nano G star open, right? And then we have given the result in this regard that gives the relation between the domain and the range space here. And then we have given the definition of nano G star T2 space, means the Hausdorff space. The same thing, if any two distinct points, then there exist nano open sets G and H with X in G and Y in H, which are disjoint. And then a similar definition is nano G star as T2 space, where two distinct points are separated by open sets, nano G star as open sets. And then we have studied the result under the nano G star continuous functions of this one. And then we have this is an equivalent definition for nano G star as open sets. And then here we said that every nano TK space is nano G star as TK space. This is the relation. Why this is the relation? Because every nano open sets is nano G star as open set. Then we have taken next nano generalized star semi-regular space. In this one, we defined this definition of nano G star as regular and nano G star regular space in nano G star open sets and topological spaces. And this is a nano topological space is called nano regular space for each nano closed set f of U, such that if the point is not in this closed set, then there exist two disjoint nano open sets G and H, such that X is in G and F is in. This was defined earlier, but what we have done the nano G star regular space. That we will be using the nano G star open closed and the nano G star open sets in the same idea. And then this is the relation, every nano regular space in nano G star regular, because every nano closed and nano open is nano open and nano closed set here. And here it is the relation under the nano G star irresolute function. We have studied that it remains valid until that. And then we have studied the nano continuity and strongly nano G star as open function. U is nano G star regular space, then the image space V is also nano G star regular. That's the proof over here. And then we have studied this one under Nano star continuous and star closed functions of this relation. And then we have taken some more regarding results by using Nano star regular spaces. And then we have given some equivalent versions of Nano Topological space to be Nano G star regular space. These are 1, 2, 3, 4, 5. Yeah, these 5 relations. Then we proved that these are equivalent versions of this one. And then we have almost nano regular space. If for every nano regular closed set F, X is not there exists disjoint nano open set G and H such that X in G and F is contained in H. And then we have extended this definition. This is a new introduction of this one. We have given nano G star as regular space by using the nano G star open sets. Okay, then we have given the relation. Every almost regular space is almost nano star regular, and every G star regular space is almost nano G star as regular. Then these are equivalent versions of this, where we are using by using the definition and some closed sets and or nano open sets, and we have given some equivalent versions and the proofs of this. Then because we have to proceed within time, Nano Generalized star semi-normal spaces. Here we have introduced Nano G star normal spaces, almost Nano star normal space, mildly Nano G star open spaces by using Nano G star as open sets in Nano Topological spaces. And here's the definition for this nano normal space as usual. And then we have extended this definition to nano G star as normal space, that if for any two disjoint nano closed sets E and F, there exist two disjoint nano G star open sets, not nano open set, but nano G star open sets, okay, containing both and are disjoint also. Every nano normal space is nano G star as normal. This is the relation of this one. And then we have used this under the nano continuous functions of this. We have given the proof. And then we have used the continuity and the nano closed functions. And then we use the nano star irresolute property of function. And we have seen that it is holds under the nano star irresolute and closed functions also. Okay, then we have nano G star as continuous, strongly is open function, and it's a normal space, then the image space is also nano star as so normal. Then these are equivalent versions of nano star as normal space here, and we have stated and we have given the proofs of this, that these all are equivalent. And then we have another one. This is normal, and we have equivalent versions of this with the proof. And then we have a definition of almost nano G star normal space. If for each nano G star as closed and nano regular closed set B such that disjoint, then there exist disjoint nano G star as open sets containing, one contains the first set A and the second contains B. And then these are equivalent versions for this nano topological space to be almost nano G star as normal, where we use the closures of these sets. And these are the proofs of this. And then we have Eurasian and nano G star Eurasian space. If for each pair of distinct points there exists nano G star open set G and H such that one contains the one point, the other contains the other point, and the intersection of their nano G star closure is empty. Okay, then we have studied this result under the nano star irresolute and non-injective functions, that this property is true. And then we have used this one nano G star open function under this. And then we have strongly Nano G star closed and sets. We studied this, the inverse image of this, it holds, and we have some more properties using a Nano G star continuity properties. And then we have this function to be almost Nano G star irresolute. We have given an equivalent version for this one by using the closure of this. And then we have another property for the same almost Nano G star irresolute function equivalent with proof. And some more Nano G star open continuous and almost Nano G star irresolute functions from Nano G star open sets to be this, then the image space is also Nano G star as normal. Okay, then we have some definitions about this one, about the function here. We have given because we are going to use it in the next results here. About this, we used it here, given some definition, and then we have shown the relation between this Nano G star as normal, almost Nano G star as normal, or Nano G star as normal. The conditions are not true. Then we have given some equivalent versions of it. And yeah, then more results we have given. Okay, Nano Generalized star semi-compact spaces. Now we have used these sets to define a Nano G star as semi-compact spaces here. Now a Nano Topological space is called Nano G star compact if every Nano G star S open cover of this Nano Topological space has a finite subcover. And then we have given some the results and with their proofs this. And this is the relation between every Nano G star as compact space is a Nano compact space. Every Nano G star is closed subset of a Nano G star as compact space is Nano G star compact also. And then we have given this result under the Nano G star as continuous functions, that this is also true. And then we have used the Nano G star irresolute functions for this one to study that the image space is still Nano G star as compact. And we use the equivalent versions of this. A Nano object space Nano G star compact if and only if every family of Nano G star is closed set of this Nano Topological space having defined intersection property has a non-empty intersection. This is true in set theoretic topology, so we have extended to this one also the same thing. Then it comes about the Lindelof space. Also this a Nano Topological space is called Nano star Lindelof if every cover of Nano Topological space has a countable subcover. Then we have given the relation Nano G star compact spaces, Nano G star Lindelof space, and we have given its image under the Nano G star as continuous function. This property of Nano G star Lindelof remains valid. Okay, then we have a Nano Topological space is countably Nano G star countably compact if every countable Nano G star open cover has a finite subcover. So then we have given this relation between this Nano G star as Lindelof and countable G star compact space. These are with Nano G star compact space here, given the proof of this, and this is the, we studied its under the irresolute function of this property of this. Then Nano Generalized star semi-connected spaces. A Nano Topological is said to be nano-connected if this Nano Topological space cannot be expressed as a disjoint union of two non-empty nano open sets. Okay, then it says two non-empty subsets A and B of a Nano Topological space are said to be Nano G star as separated if the intersection of one with the Nano G star closure of the others in both cases is empty. And it is called Nano G star as connected if there is no a Nano G star as separation of U. Otherwise, we will call it disconnected, Nano star connected. Okay, then we have about the separation, and then we have result. If G and H are Nano stars separated, and A is contained in G, B is contained in H, then A and B are also Nano star separated sets. Then we have another similar property of this, and two distant nano G star closed subsets of a nano topological space are nano G star separated. And we have another property of this one, equivalent of this, which we have given the proof. And nano this is connected if and only U is not a distant union of two non-empty star sets. And then we have studied this under the nano star continuous functions of this property holds. And then we have under as you the nano star irresolute functions, this property valid. Then we have given equivalent versions of this nano topological space to be nano G star as connected. These are three versions, and we have given the proofs that these three all are equivalent in this one. Then a topological is connected, then U is also nano G star connected. This is the relation of this one. And then we have taken of this. This is about the subspaces. We studied the property, and then we have studied this one. E and H and H are separated sets of U. Then A is in U, then this A will be contained in G or in H in one of this. Okay, oh yeah, this is also another similar property of this. This is Ferrari. Non-topological A and B are nano star connected sets and are not nano star separated in U, then their union is also nano G star connected. Then lastly, nano generalized star semi-closed graphs of this. This is psi is a function between two nano topological spaces. Then its graph G of psi is called nano star closed. If for each point in this U cross V minus G of C, there exists a K and G star this open sets in L in this such that K cross L intersection G of psi will be empty. And then we have result in this one. This is a nano star irresolute function with V is nano T2 space, then the graph G of psi will be also nano star closed. And we have then property concerning about T1 and closed graphs here. And then we have this open mapping. If the graph G of C and G star closed, then the image space will be also ninja star T2 space. It will be there. Then we have another result by using the nano star irresolute function about the nano star closed graphs with the nano star T2 open relation. And then we have another function. The graph is strongly ninja star closed if only if this to a point and the closed set, and set is this L in this such that this property holds. Okay. Then it is another property of this, and then we have this the following are equivalent to the strongly ninja closed graph of this one. And the proofs are given. The graph is strongly ninja star closed. We have a conversion of this one. Then about the T2 and the star irresolute functions. And this is also concerned with the ninja star irresolute and strongly ninja star closed graphs. And both makes the ninja star S to T2 space. So we have introduced the notions of nano G star separation axioms, namely nano G star ST0 space, nano G star ST1 space, nano G star ST2 space, nano G star S regular space, nano G star S normal space, almost nano G star S normal space, mildly nano G star S normal space, nano G star compact space, nano G star connected space, nano G star S closed graph, and strongly nano G star closed graph in nano topological spaces. We have investigated fundamental properties and characterizations of the spaces in nano topological spaces. I intend to continue to investigate further properties and characterizations of nano G star continuous, nano G star irresolute functions, and by using Nano G star open set and Nano G star closed mappings in Nano Topological space. This work will be expanded in the future with some real life applications. So these are some reference for this paper. So thank you very much for all of you. Okay.